Okay, mathematicians, students, this is my first video, so please bear with me. There may be some mistakes. My handwriting may not be perfect, but hopefully you will get out of this exactly what you need to be successful on the quizzes. Our first topic is solving equations that are in one variable. You may have done this before and you might remember doing this in other classes. But your main goal when you're solving equations in one variable is to find out what the value should be for the variable that's being used in the problem. For instance, I have a simple problem up here and you may already know the answer to what do I have to add 1 to get 7. But most importantly for our job in solving equations in one variable is knowing the steps that you have to go through to be able to find out what that variable should equal. And when you solve equations, basically you are undoing all of the things that the order of operations expects you to do. And if you remember order of operations, I know from my students in the past, they remember the acronym PEMDAS, and you have to excuse my handwriting. But the P, if you remember, stands for parentheses. I like to call them grouping symbols. E stands for exponents. M, multiplication. D, division. A, addition. And the S is for subtraction. And when you are using the order of operations to simplify a problem, you start from the top of this with parentheses first. When you're solving an equation for the variable, you actually work backwards and you start from the bottom of this and you work up. And you undo the order of operations. Okay, so our purpose is to undo all of these things. So our problem does involve addition, which is right here on the PEMDAS area. But in order for us to undo addition, we have to subtract. So we would undo any addition first. And when I subtract, I have to be fair. I have to be equal. Whatever I do to one side of the equal sign, I have to do to the other. You might remember Miss Wagner or Mrs. Garvin referring to it as whatever you do to one side of the river, you have to do to the other. Typically, I will not draw the line there to show you the river. The equal sign is what divides my river, and that's all that I use. But I know that you are familiar with maybe talking about it as a river. When I have a +1 and a -1 over here on the left of the equal sign, that converts to 0. So x plus 0 leaves me with just an x. Over here on the right-hand side of the equal sign, I have 7 minus 1, so that gives me 6. In order for my original statement to be true, I have to know that x is equal to 6, because 6 plus 1 does give me 7. Okay, so let's try something different. Whoops, you have to excuse those marks. Okay, we'll try another equation. X, 2x equals 14. What number would I multiply by 2 to get 14? And again, some of you probably already know the answer to this. And this problem only involves one mathematical step. So there's only one thing that I have to undo. If there were more than one step in the problem, I would first start with undoing addition or subtraction, and then undoing multiplication and division. Those are probably the most common types of things that you will have to undo. And we'll talk about these here in a second. So to undo multiplication, because that's what is happening to the x, I have to divide. Whatever I do to the left side of the equation, I have to do to the right side of the equation. So 14 divided by 2 leaves me with x equals 7. And if I were to plug 7 into the original equation, 2 times 7 does equal 14. I always ask myself that question. Yes, that is true. So the answer x equal to 7 does work. Okay, let's try another one. If I have a problem that involves division, x is being divided by 3 and my answer is 7. That one's a little bit harder. You might not be able to know off the top of your head, what number can I divide by 3 and get 7? Some of you probably already do know, some of you may not. And again, if we follow the order of operations and we undo addition and subtraction first, well, this problem doesn't have any addition and subtraction. So then our next step is to undo multiplication or division. So this problem does involve division. How do I undo division? Well, I have to do the opposite operation, and that would require multiplication. Whatever I do to the left side, I have to do to the right side. And in doing this multiplication, what happens is these 3's, some people will say they cancel out, but technically what they're doing is they're simplifying to a value of 1. These are reducing to 1. And if I have a 1 times x, that's still x. And if I divide x by 1, x divided by 1 is still just 1. And 7 times 3 is 21. So is it true that 21 divided by 3 equals 7? Yes, it is. So we know that the solution to this problem is 21. Okay, let's try anew. A little bit more complicated here. This problem involves more than one step. And again, let's keep in mind our order of operations. And we have to undo the addition and subtraction first. We start at the bottom and we work backwards. So in this problem, I see that on the left, over here where the variable is, I need to undo the subtraction of 1. In order to undo that, I have to add 1 to both sides. So that leaves me with 2x equals 14. Now I can move to if there's any multiplication or division. I'm going to undo that next. And I see that over here x is being multiplied by 2. So to undo that, I have to undo multiplication, I have to divide. These simplify to 1's. And you don't have to necessarily write that, but I just want you to realize that they're being simplified. They're not canceling out. And 14 divided by 2 leaves me with 7. Is it true that 2 times 7 minus 1 equals 13? This is one way that you can have, that's a question mark, one way that you can have to check your final answers. 2 times 7 is 14. 14 minus 1, does that equal 13? Well, sure it does. 14 minus 1 is 13, and so it does equal, the left-hand side does equal the right-hand side. So the solution for x is 7. Okay. And one that involves some parentheses, exponents we'll save for a later unit. Let's take a look at something like this. Okay, so we have our order of operations here. There are times when you can actually divide both sides of the equation by the number that is out in front of a set of parentheses. And the reason I would say divide is because when a number is in front of a parentheses, it indicates there's multiplication. So to undo that multiplication, we would have to divide. The only problem with that is if the number over here on the right that you're dividing by, or that's being divided, if 2 doesn't go into that number evenly, then you're introducing fractions into your problem, and I know that not all of you like to deal with fractions. So what I usually tell my students is that you can't solve for a variable when it's on the inside of a set of parentheses. So what you'll need to do is you'll need to eliminate that set of parentheses, and in order to do that, you need to distribute. So if I distribute that 2 to the parentheses, I'm going to end up with 2 times x minus 2 times 1, and 2 times 1 is 2. Now I am basically at a problem like the last one I did. I start down here at the bottom, and I eliminate addition or subtraction first. Well, I need to eliminate this subtraction, so I need to add 2 to both sides. Whatever I do to one side, I have to do to the other. 12 plus 2 is 14. To undo 2 times x, I have to do division, because division is the only thing that will undo multiplication, and I find out that x is 7. And I can check this again. You can always check your answer when you're solving these equations in one variable. Whoops, this was a 12. So 7 minus 1 is 6. Does 2 times 6 equal 12? Yes, we know that 2 times 6 does equal 12, so x equals 7 is an acceptable solution to this problem. If you feel that you need more practice, I will have worksheet problems and pages that you can use to get more practice on solving equations.